Well, hello friends. Today we're going to work on the browser again because it's been a while and I'm doing so much low-level stuff lately that I feel like it would be good to do some higher level business. So today we're taking a suggestion from Swirl Studios, who's asking about showing HTML attributes and CSS properties in the DOM inspector. And I think that would be a really neat thing to do because currently we can't really see what these what attributes these things have, and we also can't see the CSS that's applied to each element, and that would be really cool. So I think we're just gonna build some simple UI for this, at least to start with. We'll make maybe like the bottom half of the inspector window can be information about the currently selected element, and we can put the CSS attributes at least in the bottom, and then maybe we'll put the attributes as part of the tag. It might be the easiest. So let's take a look at this. I haven't looked at this for a while, so no DOM tree model. DOM tree model is excuse me, at least the G model that drives the inspector view. So let's see. Right, so when we click on the inspect menu, then we trigger this action right here, which creates a new DOM inspector window if we don't already have one. And then if we have a document in the HTML widget at the moment, then we will create a DOM tree model wrapping that specific document. So I think the DOM tree model actually, yeah, it keeps the document alive. So you can actually open one of these inspectors like this, and even if you navigate away from the page, you still keep this inspector open. That's it's this little thing that actually bothered me a lot about some other inspectors I've used in the past. Because what if I want to look at it after it goes away? Anyway, so let's see if we can just show the attributes right away. So that should be pretty easy, because what we currently do is for, if it's not a text node, it's a regular element. So here's what we do currently, but we can just make a string builder, and we will do something like this. And then if we do have attributes, I guess we should auto element is to element, because all nodes can't have attributes, but elements can have attributes, so we got to convert it. Of course, we'll need element.h for this. Cannot bind because node is a star. Oh, wow, let's change that. Have an excuse to use some dots. It's fine with me. So we'll add the tag name, and then as long as, I guess we can do element.tagname. This is actually nice because something that happens, I don't know, many people don't know about this, but if I'm doing node.tagname here, then this is a virtual function in the node class, and it's pure virtual. So if I have a node pointer, as I do here, so this is a node reference really, but it's a node type, and I'm calling tag name on it, then this has to do a virtual dispatch, which is normal. But if I tell a compiler, because I've casted it to an element here, and I let the compiler use an element typed reference or pointer instead to call tag name, then the compiler can go and look at the declaration here and see that there's an inline definition of this, and it is final, which means that it cannot be overridden in any subclasses of element. So the compiler can now actually inline this even though it's virtual, just because I give it a tighter type. So I think that's like a nice little thing. I always like to use the tightest or the narrowest type possible, because it gives you this free virtual inlining when used correctly. So anyways, let's see. Element, do we have attribute count? I guess we have for each attribute. But I really want to look at, I really want to iterate over the attributes myself. Well, it's just a vector of attribute objects. We can just expose it. We'll just expose it like this. As a const. Yeah. Okay. Because then we can do this and I guess we'll do a space followed by, oh, actually, do we actually need this? Maybe we don't. Maybe we can just use for each attribute. Element for each attribute. And is that attribute or no, it's name and value. Okay, so very, very pleasant API actually. Name, builder append, equals. Something like that. And then we close the tag and finally return the builder to string. Oh wait, maybe I can just do this way now. Did that work? No, it didn't compile. Okay. Oh, of course. Incremental build's actually working. That's pretty cool. Man, I've been like really deep in low-level CPU stuff in the last 2 days, ever since that CTF thing and the exploit. So it's nice to do some high-level stuff again, or higher level at least. Oh, crashity crash. Where do we crash? Downstream model data. And why is that? To element. So something is not an element, I guess. That's okay. So if node is element, if it's not an element, then we will just return string. We'll just return the tag name. Because I guess that the document, which is the root node in the tree, it's not an element. The document is its own type of node. So we'll say for anything that's not an element, we'll just return the tag name. Okay, so yeah, that's this one right here. It's the document. And I guess we also have a doc type actually. Okay, so now we can see the attributes here. Pretty nice. We didn't have so many on this page, but maybe if we open in a more interesting page. Oh. Okay, I was expecting you people to put some more things. Okay, here. That's kind of nice. Maybe we should quote these. I don't know, it doesn't have to be perfect, right? We just want to do something, but I think we can quote them also. I think that might be a little bit nicer. But other than that, let's go and look at adding a CSS properties table to this thing. So that would be here where we're building the DOM inspector window. Now we're not only going to have a DOM tree view, but we're also going to have a DOM element style view, something like that. And we're going to put them in a splitter, I think. Wait, where are all these variables? Oh, here, okay. DOM tree view, DOM element CSS or style table view, something like that. Why do we need to save those, by the way? DOM tree view. Do we use those from the outside? Seems like we don't really. I don't know. Do these actually need to be outside? The window needs to be outside, but these other ones don't, I think. And this one should be a table view. Where is the tree view? And then let's make a splitter. So splitter is gsplitter construct. We need gsplitter as well. Okay, now we have a splitter, and then we're going to put the tree view in the splitter. Oh, and we got to say that it's a vertical splitter. Okay, and then we're going to also not set the DOM tree view as the main widget of the inspector window, but rather we're going to have element style table view. It's going to be a table view construct splitter. And he doesn't need to have any logic when we select stuff, but this guy does. So he will have to do some DOM element style table view. Oh, I guess this is maybe why we need to keep these outside, or do we? Maybe we can just do that. DOM tree view. This is getting a little convoluted to do in a action callback lambda. So let's do something a little bit more serious. Let's see. Where is this? Is this in browser? So I guess we'll do it in the browser here. We'll have a inspector. Okay, and then we will just put this in a separate thing. Do we need? We don't need that many things, but inspector widget, something like this. Oh, I wish I would have called it inspector widget. All right, almost there. Okay. Okay, nothing terribly exciting so far. Style table view. This will be our CSS style table, and this is going to be our DOM tree. And we'll need to forward declare these. And then let's see. Parent. Okay, now here we can just say if there's no DOM inspector window, then we make one, and then inspector widget is inspector widget construct with no parent and DOM inspector window set main widget DOM inspector widget. All right. And we gotta include it. Okay, now all of this good stuff here is gonna come with us to the inspector widget class. Parent, oopsie doopsie. Okay, and then we get to include some files. Just need table and not tab widget, but table view. Okay. Oh, and of course the splitter. How could we forget? And then we don't need it here, so we can just get rid of it. I think we'll be able to get rid of the tree view as well as the table view. Come on. All right. And get rid of those. And actually, let's just use ref footers for these. No point in using raw pointers if we can avoid it here, because these things are reference counted anyway. Okay, so then I guess when we create the when we do this, let's see, how do we do this? Call the DOM inspector window. Let's be a little hackish here. Inspector widget is inspector window main widget, because we know that it's inspector widget in this case, because we set that up to always be that way. And here we'll just say set document HTML widget document. In fact, we can just set it up this way. Straightforward. Okay, and then we'll have set document, HTML document, just document. And ref footer to document. Set document DOM, what's it called? DOM tree model, libHTML DOM tree model. Maybe this inspector thing should live in libHTML actually, because then that would allow you to open up an inspector in any app that uses libHTML, like the IRC client or the help browser or whatever. It might be useful, but right, we'll build it in browser and then we can migrate it to libHTML later if we want to. So we're going to need some DOM stuff here. I'll just grab document directly. Okay, and then set model. CSS property model. We'll make one of those. Or actually, it's not a CSS property model, it's a DOM element style model. We'll construct one for the node. So if node is element to element node else, because only elements have style. So if you select something that's not an element, we will not show the style. I think that's probably okay. Style table view is like that. Okay, great. And of course, if mDocument is already document, return. DOM tree view, set model, DOM tree model, construct, document. That's cool. Oh wait, what is it? Create? Should use create for this one as well. Okay. That's nice. Then we have to invent this DOM element style model. So DOM element style model, and I guess we'll have to build it. DOM tree model, DOM element style model. So this is going to be a traditional table model, so we'll just grab the usual things from gmodel and DOM element style model. The GUI gmodel class DOM element style model. Final public gmodel. You can go down here. All right. And then we want to create a constructor function for this, or a construction helper function that takes a DOM element, and I guess we can make it mutable because maybe in the future it would be cool if you could edit these. So let's go with a mutable element pointer. I guess we'll say non-null, rough better because it's never going to be null. Okay, and then column count will be 2, or let's say return column count. These are going to be overrides also. Enum column, property name, property value, and count. So row name we can just ignore. Column name, should implement that one. Column metadata I think we can ignore. Data we definitely have to implement. Update we can just call it date update. Or well, let's implement that actually. Parent index ignore. Index will. I think we can ignore it. Index is mostly interesting for tree models. Sibling ignore is editable. Ignore set data tree column. Blah 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 blah. Okay, so it's pretty simple actually. DOM element style model. Oh, we forgot to declare a constructor. Okay. Boom. And I guess this one can just do return dot new element. Okay, let's do these. Style elements. Row count is the row count is how many rows are in this, which is well, let's have a helper that gives us an element, by the way. Okay, so element, so we'll need element dot, how do we get the style? I forget how this works. I guess we can get it from the layout node style. So style is element layout node style. If the element has no layout node, then there are no rows. Because if something is, for instance, display none, then it will have no style. Although then we would want to show it, actually. So that's a little annoying. How do we show the style of an element here? We don't want to, I mean, we want to show the CSS properties, not the computed style, actually. Computed style is separate. Now we're just interested in the CSS, right? So, how do we find this? We have style here. I guess we can, we might have to run the selector thingy to find all of the style that applies. Because we don't have like, we don't have the style handy in that way. Like we don't have a set of CSS properties that apply to this element. But we could make one. It's with this function right here, resolve style. This will go through all of the style sheets and find everything that applies to this particular element, and then return a style properties object containing all the CSS properties and their values that apply to this element. I think that's probably what we want. So let's go with that. So actually that means that we're going to need to do a style resolution at one point. So, but that's okay. So we'll do a ref footer to style properties. Style. And when we construct this guy, we'll do, hold on, style resolver, m style is style resolver, element document dot style resolver dot resolve style for this element. So we have an element, but we also need the parent style. This is a little bit annoying. Maybe we can just stash this style properties object somewhere. Maybe we can just keep it with the element, actually, because why couldn't we? Nobody's going to stop us. It's going to use a little more memory, which you can do better on in the future, but it's not that heavy so far. So when we resolve style, which is usually when we create a layout node, or when we recompute style, then we can just say m style is style. We'll call it the resolved style, because it's not the computed style, it's just the style that we resolved. Wait, am I adding that in the right place? Yes? Okay. Wait, why don't you like it? Resolve that. Oh, okay. There we go. And that's const, but I'm just gonna be a little sneaky and just do this. That's not how you do that. Okay. Yeah. Okay, the way that we construct the box tree, the layout box tree, needs to be re-architected a little bit anyway, so I don't feel terribly bad about that const cast. But this means that we don't need to do style resolution in the resolver, in the inspector anymore. Instead, we'll just be able to grab it from element as long as we expose it. So properties, we'll do it like this: resolved style. Whatever. And this will most definitely be const. So I think we can give up our dream there about a mutable DOM element style model for now. We'll just say const. That'll be okay. Now, now we can instead, if the element has no resolved style, return null pattern. Or 0 rather, and then otherwise element resolved style. Can we get a property count? Maybe it doesn't have a property count. We are going to need a property count. That's pretty easy. We'll just say int property count. There we go. Okay. Don't need to worry about the style. Don't need the resolver. Okay. And we're back on track. So now each element stores the resolved style that it has, and now we just need to implement these three guys, and we should be good, I think. DOM element style model. This one is easy. Column count. Column index, column name rather. What am I saying? So many column words. So for column property name, return name. And for default, we will assert not reached. Okay. And then we have just getting everything into the right place. Okay, now update. I think we can just call did update here, actually. It doesn't have to be more complicated now that I think about it. But data, this is interesting. So if role is role display, let's just say this for everything else. So for the display info, we'll do element resolved style dot property. Oh, we don't have these guys. They're in a hash map. Well, that's a bit silly. I guess we can just copy them over into a vector. Because, yeah, they're just style values anyway. We'll just copy them over into a vector. Non-null ref putter vector to style value. Okay. So this simplifies things a little bit because now we can just do if element dot result style, then element result style for each property. Name, auto. How does this work? We get the property ID and the value. Okay. Property ID and the value. Right. So we need to store them like that, I guess. So that'll be something like a entry, we'll call it maybe. And an entry will be a string, property name, or why not just string value. We'll just resolve everything here on the fly. Okay. Then we will need CSS property ID. Okay. There's some toString or something in here. So string from property ID, right? String from CSS property ID. String from property ID. Entry name is this. Value is value. ToString and entry. I feel like we should have called this value instead. Or maybe we'll call them entries. That's so weird. Value is a bit better. Okay, now this becomes a bit easier. We just do values size, and here we can just do mValues index row. Index column is column property name. Then we'll do the name. Alright, so we can also do something like this. Value.value. Okay. Whew. Well, that was all over the place. So let's see how this works out. Had a couple of bad starts there. It's a const style value. Well, my bad. Okay, it's very nice. Nice and friendly API. I don't know why I thought this would be a pointer type. It's an ampersand right here. All right, so what are we forgetting? Inspector widget. We are definitely forgetting to include the DOM element style model. No. In main CPP, we have a tree view somewhere. Oh, I guess an inspector widget. Because this destructor is inline, that's not going to work. But we'll just put it out of line. So that main CPP doesn't try to call destructors on things it doesn't know about. Did we forget the splitter? No, wait, hold on. What's wrong here? We have to give more arguments to the splitter constructor. We have to provide a parent, of course. And the parent is this, actually. Okay, what else don't you like? You don't like this because it's an invalid static cast from node to element ampersand. Because the element class is incomplete. Okay. Now, let's have a look at this. Oof. That did not go the way I expected at all. Okay. Where do we make this? So we construct one, and then we set him as the main widget of the DOM inspector window. I think we are forgetting to give him a layout, so his splitter child ends up taking up no space. So we'll do a box, gbox layout, vertical. And we will actually need to include gbox layout for that. Okay, this is more of the UI I was hoping for. And okay, let's kind of shit with this, but if we fix that up, we can see the properties. Now that's pretty cool. Of course, yeah, actually, I quite like it. So this is the resolved CSS properties that apply to some individual element. You can see here we're using an internal property to implement the link color. Pretty cool. It's very nice. This could probably be better in a million ways, obviously, but it's a cool start. So let's make sure that we automatically size those table columns, because it's going to be super frustrating otherwise. Okay, why can't I type? Set size columns to fit content, true. And let's open up this cool web page here and check it out. Oops. Oh, look at this, by the way. It's pretty cool. I think Kafka made this. tiling. If you drag a window to the edge, it makes them do that. Kind of neat. I guess we can stick in that mode for now. So we can see the attributes here in the tree view, and then we can see the CSS style that applies, and these columns, they size up perfectly. Very, very nice. And then, of course, we could probably come up with more interesting visualizations of some things like, you know, colors. We could show the color and things like that. But it's really, really neat. I'm very pleased. Okay, so let's do some commits. What did we change? So much stuff. Okay. I guess we can do the element change separately, where we just store the style that we resolved for each element in a resolved style member. It's just a pointer to something that's going to stay alive anyway, so it's one pointer per element. It's not particularly heavy. I'm stuck in this in this WebKit way of thinking, where like you care about a pointer on element, but here I really don't care. It's not a big deal because we're so far from having to care about that type of stuff. So have elements keep a pointer to their resolved style. This will make it easy to implement a simple element style inspector. Okay, and then what else do we have? I guess this one was just adding the attributes, right? Showing attributes in the DOM tree inspector. So we can show that one, or commit that one separately. HTML, show include attribute element attributes in the DOM tree model. We simply expand the attributes inside the element item name, so they look like natural tags. That's pretty neat. Okay, and then what else did we have? The rest of this, I guess, is kind of gonna have to come in one go. Actually, what was this change? Style properties.h, just exposing the property count. I didn't end up needing that. So let's not commit that. Oh. That's better. Okay. Browser plus libhtml. Add resolved CSS properties, resolved element style to the DOM inspector. Selecting an element in the browser's DOM inspector. We now also show the resolved CSS properties and their values for that element. Since the inspector was growing a bit more complex, moved it out of the show inspector action callback and into its own class. In the future, we will probably want to migrate the inspector thing to them down to with HTML. But for now, we can keep HTML to make it accessible to other clients of the library. But for now, we can keep working on it inside the browser. Okay, so I think this is going to be it for today's video. So if you made it this far, then I thank you for watching and for hanging out while we work on this browser stuff. Look at old Serenity. Such a good times. Let's bring up the DOM inspector and see all of these images. Where are they? Oh. So link to the image. Very cool. It'd be nice if you could like right-click on something and select inspect and it would show up here, but I'm not going to do that right now. So neat. Wait, why can't I? Oh yeah, it would be cool if you could select this and it would highlight the link element. Anyways, so much stuff to do in the browser, obviously, but this has been a nice feature that definitely is gonna make it easier to work with this stuff. So thank you very much to Swirl Studios for suggesting it, and thanks everyone for hanging out while we implement it. I hope you saw something interesting, and I hope your projects are going okay. I guess I will see you next time. Bye.